Hey everybody, this is Unit 3, Video 3. I'm going to go through some basic applications of right triangles. The first two examples will involve an angle of elevation and angle of depression problems. If you're comfortable with those, feel free to fast forward, but the third example is new to us in trigonometry, so please make sure that you view the third example. You will need your calculator, so make sure you've grabbed that and then we can continue. First example, Missy is flying a kite with her younger brother. The kite string is extended 525 feet and has an angle of elevation of 62 degrees. Find the height of the kite above the ground if Missy is 6 foot tall. So let's go ahead and start by drawing a picture. So we've got somebody standing and they're holding this kite string. So we got our kite. And we know that the kite string is 525 feet long. We also know that the angle of elevation, so the angle that we're going to get here, is 62 degrees. What we're looking for is the height of the kite. So we want to know how high above the ground the kite is. This additional information of Missy is 6 foot tall means that whatever we end up finding for our height, we have to add 6 feet to it because the kite string is not attached to the ground, it's attached to her hands. So we're using 6 feet as the additional height that needs to be added to that, to the height of the kite. So let's go ahead and solve this using our right triangle. This is my x value. I have 62 degrees and 525. It's not necessary to always redraw the picture, but sometimes that helps take it out of the situation and make it a little bit more simple. So here I've got an opposite and a hypotenuse, so I'm using sine of 62 degrees will equal x over 525. So that will be 525 times the sine of 62. Make sure that your calculator is in degrees when you do this, and you end up with your x value to be 463.55 feet, and I know that I have to add another 6 feet because of Missy's height. So that leaves me with 468.55 feet is the height of the kite. This next one, a fisherman has dropped an anchor in the lake with a chain 153 feet long. The boat has drifted 60 feet from the place he dropped it. What is the angle of depression of the anchor with the surface of the water? So I'm just going to draw a little picture. We've got the boat, the water, the chain. So the chain is 153 feet, and we know it says here that when he dropped it originally, he was 60 feet away. So what we're looking for is the angle of depression, which would be this angle up here. So let's go ahead and set that one up. This time I'm looking for an angle, so I will be using our inverse button on the calculator, or that little -1. And we've got here, this seems to be the adjacent and the hypotenuse, which is cosine. So the cosine of theta will equal 60 over 153. That means cosine inverse of 60 over 153 will give me my theta value. And this is measured in degrees. So make sure, again, your calculator hasn't changed. It should still be in degrees. So cosine inverse of 60 divided by 153, and I get 66.9 degrees. You'll be rounding to whatever the directions say on your assessments. So just be clear, if it says whole degree, that this would be 67 degrees, but if it says to a tenth of a degree, 66.9 degrees is appropriate. If you had made a mistake and you had done the cosine of 153 divided by 60, you would have noticed that it gave you a domain error, and that won't work. So that just gives you a reminder that you have to make sure you put the cosine in correctly into your calculator. On to our third example. Okay, so this picture is set up where I'm going to try to find h. My job here is to find the height of this triangle. I can apply this by saying, the height of this tree, and there's two different positions in which we're looking up at the top of the tree, but essentially I'm still looking for the height. So I'm starting with the picture, and we'll do some more word problems to follow. So I'm going to put an x here on this measure, on this part of my base. And I'm going to be looking at the small triangle, and I'm going to write a tangent expression for this triangle here, and only this triangle. So that would say that the tangent of 75 degrees is equal to h over x. And that doesn't really help me at all because I have two variables. Now I'm going to use the large triangle and I'm going to write another tangent expression, and that one is going to be the tangent of 46 degrees equals h over, and my base is 215 plus x. So that's my adjacent on this one. What they both have in common is they both have h. Yes, they both use x, but independently they both use h really nicely. So I'm going to solve these both for h. So this one is going to be x times the tangent of 75 equals h, while this one is 215 plus x times the tangent of 46 equals h. And that just takes the denominator and multiplies it to the other side. Since they both equal h, and h in my picture is exactly the same height, I'm able to set these equal because they share the same height. They share the same opposite. So I'm setting them equal to each other. That gives me x times the tangent of 75 degrees will equal 215 plus x times the tangent of 46. Now they're equal to each other. Since I want to find out what x is, that's going to help me find h. I'm going to distribute on the left-hand side here. Tangent of 46 is entirely one thing. I can't have a tangent without an angle, and I'm not going to have an angle without a trig function. So they're stuck together. Don't treat them like they're two different things. So my left-hand side will stay the same, tangent of 75. And the right-hand side will become 215 times the tangent of 46 plus x times the tangent of 46. Since I have two things with x's, or two pieces with x's, I'm going to put those together onto one side. So I'm going to subtract this x tangent of 46 to the other side. Changing pens again so you can see my next step. I'm going to have x times the tangent of 75 minus x times the tangent of 46 to equal 215 tangent of 46. My right-hand side, 215 times the tangent of 46, is just a numerical value. It's a messy numerical number. It's a messy value. You type in your calculator, you're definitely going to get some decimals. So we're going to leave that alone for right now. On the left-hand side, I've got x times tangent of 75 minus x times the tangent of 46. Since they both have a factor of x in them, they both have multiplied by x, I'm going to factor it out using a GCF. That's going to leave me with x times the tangent of 75 minus the tangent of 46 to equal 215 times the tangent of 46. Since the tangent of 75 minus the tangent of 46 is just a number, again, it's a messy number, but it's a number, I'm going to be able to divide both sides by the tangent of 75 minus the tangent of 76. This is what happens. I get x to equal this messy number 215 times the tangent of 46 divided by this parenthesis quantity of tangent of 75 minus the tangent of 46. I have to enter it in the calculator just like this, and I have to use parentheses. So I want you to go ahead now and enter that in the calculator just as you believe you should, and let's check our answers together. Okay, I came up with x to equal 82.565. Okay, that's the x value that I got. If you didn't close the parentheses around the tangent 75 or around the tangent 46 before you opened up the next set of parentheses, then you've included it inside and it becomes messy. So again, you need to make sure you close all of your parentheses and that you use parentheses for this denominator. Well, x wasn't exactly what we were looking for. What we were looking for was h. So I'm going to take this x value that I found, and I'm going to use the one that's actually in my calculator when I do this. And I'm going to place it back into our very first trig function, which what I would do, or better yet, let's place it right here. Because all I have to do then is multiply my final answer by the tangent of 75 and I come up with a value of h. So my height of this triangle is 308.14. And whatever I'm asking you to round to, this would be to the nearest hundredths place. Okay, so if you need to go through these steps again, or with me or with somebody else, please make sure you are able to complete a problem like this.